So we have the wonderful opportunity to come down to the Lennox Technical Training Facility here in Richardson, Texas. And I'm telling you what, Ty, this is pretty cool. What do you think?
It is absolutely awesome. There's so much stuff that I want to go play with and take apart right now, having to contain myself.
And this is just the showroom. Like, this is just the entrance into all of it. So we start out here, and every direction you go is a different training opportunity. So let's talk about some of the training opportunities that we've seen today while we were here visiting this amazing facility.
What's really awesome about here is we see that they have even from brazing. They got brazing tables all the way up to the high-end technology, the whole entire range of
VRV stuff, VRF stuff?
VRF, yes. Oh, it's just really awesome. And they have things that are opened up where you can see it. They got boards where they can actually get the hands on and practice things, and they have levels from one all the way through the high levels to equipment where they got systems that can put switches in there to diagnose these problems. Absolutely awesome.
I'm loving it. So we're going to go explore the BuildATech program, and we're going to take you on an adventure. And so let's go take a look at the Lennox BuildATech program. All right, everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. So we have a little bit of a surprise for you. We had some technical difficulties trying to bring Doug Smiley in from Lennox to be able to dive into the BuildATech program. So we sincerely apologize for that. We will work with Doug to make sure we get some errors. We think that it is in the firewall protection through the corporate IT system. So we're going to work on that, and we're going to come back later. But we have got such a fun presentation for you all today. So as you know, like the big thing in our industry right now is A2L mitigation. And I actually just got home a few hours ago. So I was out on the road doing about an 800-mile road show up through Wisconsin and Illinois, doing classes on A2Ls for distributors and contractors so we can get comfortable with this entire transition. So what we're going to do is, hey, HVACR, how's it going? So what we're going to do is we're actually going to dive deep into mitigation because Ty has also been out traveling. Ty, you go ahead and tell everyone where you're at while I'm loading this PowerPoint presentation up here for us.
Well, I'm over here in San Antonio, Texas. And it's absolutely awesome here. The weather's been great. And I'm here for the Allied Conference. And just when you think you have all the A2L stuff figured out, you go to another class and you learn a whole lot more. So it's just been interesting just getting all this information in my head, taking tons of notes, taking tons of pictures. It's just what was interesting on this side, they brought in engineers and they brought in even some of the lawyer staff of it, talking about the importance of what we do. And it's interesting, like just the placement of a sensor, how much engineering and testing. It's been so much money on testing every aspect, even to a millimeter of the height of the switch. And they say sometimes, you'll come in and somebody think, well, why did they put that there? That was just ridiculous. And somebody will change it. But some of those changes can have big performance in how a system works, especially when it's a safety component, like something as simple as a sensor. And so when they have these systems tested, they're having them UL tested, and there's another testing, I can't remember the name of it, but they have things tested to make sure that they're working in balance and in unison. Even something as simple as not changing the length of the cord. The length of the cord, they've calculated all that with the communication signals. And so they were making it very, very well known that we need to put these things where they go in the proper thing, following those instructions and not making any changes, because even though to us, like it may seem normal or it may work, it may not work within those UL safety ratings. And then you're opening yourself up to an unlikely, but still, if something happens, now you're opened yourself up to litigation, because when it comes to the manufacturer, you're going to say, hey, we said in the instructions to do it like this, and it wasn't done that way. And it all comes back on the contractor. And then so the legal side came out which I don't think about talking with lawyers much, but the legal side is coming out saying how important it was to follow these steps, whether you think they should be or not. And I just thought that was just to me it's just like a huge eye opener of thinking about these other steps that we do.
Yeah, absolutely. And so part of the entire conversation I've been having with contractors and with our distributors is understanding our liabilities and going forward, understanding that if we do anything to interrupt these safety controls, it's no different than bypassing a limit, like a rollout limit on a gas furnace. If anything happens to that piece of equipment, we have now assumed 100% liability for bypassing a safety control, and we will be held accountable, held responsible for actions that came from that. And that's the last thing that we want to do. So let's talk about these controls a little bit. If anyone has any questions along the way about this whole mitigation strategy, please bring them in. We've had an opportunity to be able to test some different controls. I'm actually going to show you a couple different styles today. We have a variety of different slides. We have some hands-on equipment that I just threw up here 5 minutes ago. So I apologize for all the sound that was happening at the beginning. We're going through that initial 5-minute startup procedure. Just like any brand new installation, we're going to go through a 5-minute time delay on installation, and then it's going to be starting its normal procedure. So I'm going to go through some of the slides that we use for this actual conversation. So things that I've been sharing over these last few days. And these classes, like last night's class, I had over 100 technicians in this class. It was very impressive, the amount of people from the industry that are here to learn about this transition. So hopefully you are all aware that we are making this very important transition from our A1 into A2L refrigerants in a very short period of time. And with that comes some new transitions. And the primary one that we're going to see is the adoption of mitigation into our systems. Okay. So, not all systems are going to get mitigation. If you don't even know what mitigation is, let's think about this for a minute. So, I've been using this analogy for people to understand mitigation. We actually introduced mitigation into gas furnaces around 1986 when we introduced the first integrated control board into a gas appliance. Where's the naysayers out there? I'm waiting for you. All right. Or maybe everyone's sitting out there just going, I see Paul Leonardi's with us today. I'm hoping he's going to get this one. So I want you to be thinking about this, and I want you to put it in the chat when we get to this point. So think about this. When we built integrated control boards, this particular one right here. So you've probably seen this training board before. I've used it in other videos. This is just a single stage Goodman 80% furnace, everything minus the original blower, which got replaced with our shaded pole motor and no door switch, which I probably need to add one on just for the fun of it. Okay. So, Todd, yes, we were going through a pre-purge just now. Correct. But no, think about this for a second. What is mitigation? Well, mitigation, Ty, is not, let me say that. Mitigation is an action or sequence of actions, okay, that is tied to a change of state. And I stump people in this class because I want you to think about this. If we take a gas furnace, Todd, you're going to appreciate this very much, right? You love sequence of operation of things. I have a gas furnace and I fail to ignite, right? I've got a call for heat. I try to ignite. I do not ignite. And I do that 3 times in a row. What happens after that third attempt? Okay, Todd, you're exactly right. Now, I want everyone to think about this. So, is that soft lockout that we go into, is it a state or is it an action? Man, I got to add a timer onto my podcast or roadcaster here. Think about that. It's not an action, it's a state where a sequence of actions begin. Okay. So our control board puts us into a state of soft lockout and initiates a sequence of operation to mitigate the potential for combustion. All right. So in the chat, I want you to tell me, everyone put in there, what happens when we go into that state of soft lockout? Man, I need that timer real bad. I know what I got. Nope. There's cricket. I needed the cricket in the background. Okay. Yes. No. Think about this. All right, Ty, I know you're waiting to jump in on this one. All right, in that state of soft lockout, what sequences will we see as actions to perform a mitigation of gases? Because remember, what gases are going through this gas valve? Either natural
Oh,
gas or propane, A3, highly flammable gas.
A3, yes.
Okay. And so we're going to mitigate that potential for ignition. And we're going to do what, Ty?
Well, we're going to close a relay or keep a relay closed so that the inducer fan continuously runs, so that in the
Okay.
case that there is combustion and we just aren't sensing it, that we're making sure that we're pulling that through the heat exchanger and out. We're also checking all of our rollouts for safety, so just
Going
in
through the
case there
limits.
was an ignition and we didn't see it, that we don't have a flame burning uncontrollably inside that cabinet, or if maybe a gas valve did hang shut or hang open and was leaking through. And we're also measuring that limit switch to make sure that we're not overheating anything. And then many of the furnaces will also bring on that blower, because the customer is going to feel, man, I feel a cold draft. And then they're going to be wanting to call somebody to come out. And that will be us. That will be where we come in.
Okay. So I want us to think about that when we talk about mitigation for these new pieces of equipment. So we're going to show you that mitigation will not be in all, but it will be in probably all of your residential split systems and light commercial split systems going forward. We have a few examples. The one that I have right now, I wish I would have had that second camera, the third one hooked up, because it's a little hard to see it. But like I said, we threw this together in like 5 minutes. So I'll move the camera around and show you. So what we're actually going to work with here is we have a fresh off from the shelf Goodman Amana Daikin 2-ton coil that is an R32 coil. So all of my local Johnstones are now stocking their in 2-ton, 3-ton R32 split systems, the outdoor units and the A coils. And what we're going to see is this little mitigation control. It's an RDS, a refrigerant detection sensor. This RDS sensor actually sits on this coil, and it is rested over the drain assembly. And then on the front cover, it has a knockout in the door, and I'll show you that here in a little bit. But I wanted to bring this down so you can see the location of this. So what we're going to see in our evaporator cabinets going forward is a type of refrigerant leak detector. And this particular one sits right here. This is one of the Sensata detectors. There's a couple different models, different brands out in the industry, but they're all very similar. This one that I got, which is the latest ICM universal control that will be hitting the market for doing installations on existing systems, so retrofitting existing gas furnaces with new A2L indoor and outdoor unit. This one is made by Thermodisc, and it's going to be a very similar one. And we'll talk about on one of the upcoming shows what we're actually doing with those sensors, because it's not just an A2L refrigerant detection sensor. Okay, so as we go through this program, think about that. Think about we've added a sensor for the protection, the safe operation of A2Ls, but this is more than just an A2L sensor. Okay, thinking about that. We're going to come back to it. Okay, so I want us to understand what mitigation is. And for that, I'm going to go back to some of this presentation I've been using for these classes so that we understand where the mitigation strategies come from. So when we look at the mitigation strategies that were developed for our entire industry, it can have a variety of different types. And I've also seen some local jurisdictions that have added their own on top of it. So it always we have to rely on what jurisdiction has the most specific code for our area. So the whole purpose of mitigation is designed to prevent accumulation and or ignition of flammable refrigerant vapors if a leak should occur. And there's not a one size fit all. So different manufacturers may operate a little bit differently, but they're going to be fairly similar. And it will depend on the classification of the installation. Okay. Now, how is that broken down? That's been one of the big questions. What equipment gets it and what equipment does not get it? So here's where it really falls into play, Ty. When we look at the M1, M2, there's actually a M3 out there, a higher capacity charge. Actually, just did a podcast with Carter Stanfield on this that is just a fantastic overview. We'll be releasing that this Friday for everyone to enjoy. We talk a lot about where these came from through ASHRAE 34 and 15.2 and what that measurement is. That is the mass of refrigerant within the system. Okay, so if we can fall under that M1 charge level, so 4.1 pounds of mass of R32 within a system, or 3.9 pounds of R454B, We don't even have to have mitigation, Ty.
That's right. My mini split doesn't have any mitigation whatsoever because it falls under that threshold.
Okay, so you ordered an R32 ductless mini split, correct?
Yes, that's correct.
Okay. And does it look any different than the R410A generation that would have been just previously before it?
Oh, it has a sticker on it.
And we
This
will
says
get to that.
A2L.
Exactly. And it's going to have a little flammable sticker, which we'll talk about as well. We'll dive into that just a little bit. But really, what we're looking at is the systems that will not be required to have mitigation will be in that approximately 4-pound range. So, ductless units, especially 1-to-1, probably not going to see any mitigation. Even if we get up into that 5-ton range, if it's a 1-to-1, there's a real good chance we're not going to see any mitigation because it's going to be under 4 pounds of refrigerant. We have window units. If people didn't understand that almost every window unit that you purchase today has R32 in it. It has for a couple years. So one of the questions that just came up, Todd, was, is that a factory charge or a TEL charge? Right? So that has been the most interesting question so far. And that will be on a total charge installation. Okay. So you will see stickers, and I got some examples of what is going to come on the equipment with the factory charge plus your additional charge. So as a technician, if we have an installation that gets above that threshold, it's going to be our responsibility to comply with mitigation. So most manufacturers have been working really hard to make sure that they don't get systems above 4 pounds of refrigerant. I will promise you that.
And
And
I noticed some of the manufacturers are actually changing their liquid line size. And I noticed that one manufacturer in particular is using 1/4-inch liquid lines. And I'm sure it has a lot to do with that sizing.
that capacity.
But also, we have to take a look at that. It's very important for us to look at those installation manuals because some equipment with 454B has the same exact 3/8 line. Other equipment with 454B may have a 5/16, 1/4-inch, or the 3/8 line, and the flex line can be different also. So these are we've always supposed to have been reading that manual for oil return alone, but now we're going to be looking at that liquid line a little bit more than we've had in the past. And I don't know, I'm not an engineer, but I imagine that this table has a lot to do with that.
Yeah, absolutely. And so what we can anticipate to see is our ductless mini splits, our window shakers, and our PTACs not having any mitigation whatsoever. So what is mitigation? Well, we've already talked about that in the gas appliances. So let's think about that from a refrigerant perspective, okay? So I did this sequence of operation to mitigate any potential gases that was on that A3 natural gas or propane in our gas furnace. So what would we want to do as a procedure for when we go into the state of mitigation? So the state of mitigation would be, okay, I have I have approached and I have met my lower flammability limit of this particular refrigerant. My sensor has detected enough that I should change my state to now a soft lockout, and I should have a sequence of mitigation. So let's all think about that, okay? Especially Paul, Todd, Froggy Beluga. Think about that for a minute. Everyone that's joining us today. And if you haven't joined in and told us where you're from, we'd love to know where you're from. We enjoy having this conversation with everyone. We want your input. We want you to be a part of this community and this conversation. So let's step back about that, Ty. So my failed ignition on a gas furnace initiated my mitigation, my sequence of mitigation, my state of soft lockout. So, okay, we should run air that. So that is an interesting one. I will actually touch that one a little bit. Okay. So on this particular unit, so let's take this new installation. And we're going to assume for a moment that this is a complete new system installation. This is my R32 indoor cased coil with its refrigerant detection sensor. We have our R32 condensing unit or heat pump outside. We have a new gas furnace, but the new gas furnace hasn't been updated to the newest version of control board that has the mitigation already, the sequence built into the control board. What would I need to do to have a series of mitigation with that, Ty? Let's think about that for a minute.
Yep, you would need
Thanks
to
for
have
joining
some
us,
kind of
George.
an interface in there. And there's two things we're going to do. One, we want to shut off the call for heating so that we shut down any potential for a flame for ignition source. So we want to shut off our W wire. So that way we don't have the gas valve dumping gas in there, and then we'll let its existing mitigation take over. And then whether it's a gas furnace or not, so we have a heavy concentration of a potentially flammable substance. Man, if we could only dilute that down to where we didn't have as high of a flammability, as we didn't have as much substance. I was always thinking about propane leaks. I said, make sure it's in an open area. If you can't do anything about it, make sure it's in an open area without an ignition source. So if we stop our ignition source, and then if we could add some more air to that, let's run the blower. If we're moving the blower, we're moving air through that evaporator coil, and any of that refrigerant that's built up, it will then dissipate throughout the entire building, the structure, or the home. And so that way, we've now brought that level down below the lower flammability limit, and it's not possible to have a flame anymore at that point.
I love it. Sounds like a great idea. So does it to Paul. Paul's hitting it just the same way. So we would want to shut down our heating cycle. So that'd be killing W. We also be killing Y if it was a heat pump in heating mode, right? We could also now energize G if we had an intermediate board. So we are going to have intermediate boards on some of our brand new equipment for a very short period of time. So I have had the opportunity, especially over these last few days, to speak to a variety of different manufacturer representatives saying that they are converting all of their gas furnace and their air handler control boards over to accept a 4-pin refrigerant detection sensor. This is a 5-volt DC sensor, okay? So in the meantime, if we do our new installation, we have a piece of equipment that does not yet have the capability. We're going to have an intermediate board. This particular one here is called the Daikin Firefly. Dragonfly. I'm sorry, fireflies. This is a dragonfly. So it's a Daikin Dragonfly, and it is an intermediate control board that goes exactly like we said, between our thermostat and our original indoor control board. Because this could have also been a retrofit system where I had a functional gas furnace, a modern gas furnace with an ECM blower motor, not a PSC. And I am now wanting to put a A2L system on there that was a HRI matchup. So what I can do is I can use our intermediate board in between the thermostat and our existing furnace's control board, and I can now do all of these sequences of mitigation for a piece of equipment.
And really,
Go ahead.
if we wanted to simplify that, we could think about it kind of as a fancy float switch. It detects that there's refrigerant, and it simply shuts off all of the controls going to the control board, except for the fan control. So it would just be like, hey, instead of having each individual of these things shutting off, hey, we're going to shut off all the signals to the indoor unit and have just our fan running, whether it's electric or gas or anything in between. And it's a very simple way of thinking about that. Of course, there's a little bit more involved to it, but pretty cool idea if we think about safety.
Yeah, absolutely. Froggy Beluga's got an interesting one about safety that we'll actually tie into here in just a little bit, and we'll answer that question for you. So another one came from Todd. Do we need solid state controls? Let's just hang on for this one for a minute, and let's run through this scenario, and then maybe we'll come back to that one. All right. So I have taken my existing 80% gas furnace. I have brought my new Dragonfly control between it. And if this was a Daikin communicating system, it works the same way. It has legacy controls. It also has the RC1 and 2 for the communicating system for like the Daikin 1 Plus thermostat. So this can be used on a Daikin communicating system, existing communicating system as well, or the new one if it hasn't had the board updated. We've actually encountered some of the furnaces in the industry that have already had the updated control board that have the 4-pin connector on the furnace ready to accept the A2L sensor. So we would not need a separate board. But in this particular application, we do. So we're going to do this. We're actually going to run this thing through a mitigation to see what actually happens, to verify our theory about what should happen if we were going to put this thing into mitigation. So in the scenario, we would have a refrigerant leak at the indoor coil, and it's large enough of a leak that it can meet the lower flammability limit for that refrigerant. And then we should go into a state of mitigation. Now, here's an interesting one for you. how much time would it take for this refrigerant detection sensor to set us into a mitigation? I'm going to leave that in the chat while I'm putting this in a place where you can actually see this thing easier. So how much time do you think it would take for my refrigerant detection sensor to put my system into mitigation once it has reached that lower flammability limit? So this was one of the questions I did in class quite often, asking people what they thought. And Ty, if we think about a gas appliance, how long does it take for that thing to typically initiate a state of soft lockout? Pretty quick, right? Okay. So with this particular sensor and this particular control, it actually does sampling every 5 seconds. And if it reaches the lower flammability limit, it will go into a soft lockout, the state of soft lockout, for 5 minutes. And it will initiate, within a few minutes, Paul. Exactly right. It's actually going to be, should be, hopefully, within a 5-second period. Okay. So then it's going to initiate that soft lockout, that state of soft lockout, and it's going to give the actions of mitigation. So it should, theoretically, shut off our call for heat, whether that is our gas appliance or whether that's our heat pump, and initiate some kind of air movement to dilute the potential for refrigerants. And since we're talking about refrigerants that would be within the cabinet, within the airstream, most logical, I think, would probably be to turn on our blower. What do you think, Ty?
Absolutely.
Okay, now, here's how we were able to verify that these refrigerant detection sensors will pick up more than just our A2 mildly flammable refrigerants. So remember the test that I did on the flammable refrigerants using the aerosol duster, because those were a non-regulated version of our own refrigerants. So I wanted to test that myself to see, okay? A2L, A1, and so I actually started at the bottom of the chart. And I went with my A1. So we're going to use 134A. And it would take a different concentration of a 134A than it would for an A2L. It should take a lot more of a concentration of an A1 because of its lower flammability. Like, remember, all refrigerants have some amount of flammability, just very, very, very minimal on an A1. So we're going to introduce a leak into our evaporator with an A1 refrigerant, and we're going to see what the sequence of operation is. Okay, are we ready?
Yes.
All right, here we go. Very smallest amount that I can pull on that trigger. Look at that. Within 5 seconds, did you hear that click?
I didn't even hear the can spray, but I did hear the click.
Yeah, very little bit. A small amount of refrigerant as I could put onto that sensor. Now, I don't know what that concentration was. I'm going to be working on that on some videos over the next couple of weeks. I mean, we're going to be putting our brains together going, okay, let's get some better math and some better demos onto this thing. We're not going to blow it up or burn it up, but we're going to have fun trying. And we're not going to burn anything up, but we're going to get you all the information that you want to know on what things would actually set this sensor off in a real world scenario. So could I use this on an A1 system for additional protection? Not a bad idea, actually. Okay. But we're going to be using it particularly for A2L refrigerants. So within 5 seconds, I went into a state of soft lockout where I actually turned power off to this thermostat. So I shut off my 24 volts to my thermostat. I turned off my call for heat, and I initiated my blower. This one's not running the draft inducer because we didn't have the combustible gases within the heat exchanger compartment. We only had it in the air stream. Therefore, we just used our blower. So what should happen is it will run for about 5 minutes, and then it's going to start resampling every 5 seconds after that 5-minute soft lockout. And as long as our concentration is below the lower flammability limit, it's actually going to clear its soft lockout, and it's going to go right back into normal operation. Thermostat's going to come back on, and I'm able to run my system again. Okay, so here's an interesting one for us, Ty. Is there a potential for a hard lockout on an A2L mitigation board? The question came up to me in the conversation, and I thought, let me think about this for a minute. Is there a way that I would have a hard lockout? Because I really don't want a hard lockout. I don't want to leave my customer without operation. But is there a scenario where I would never bring my system back on. I thought, okay, what happens if I have a leak or my refrigerant detection sensor thinks that it has a leak that is above the lower flammability limit and it doesn't? Say I had a failed sensor, and these sensors are supposed to have a shelf life of 10 to 15 years when cleaned regularly during service to make sure there's no buildup of contamination, particularly dust and other contaminants on the sensor. If my sensor potentially went bad and it stayed above my LFL after that 5-minute soft lockout, remember I said it's going to start sampling every 5 seconds. If after that first 5-second period, it recognized that there was still a signal showing that it was above the lower flammability limit, it would initiate an additional 5-minute lockout. So because it would be a 5-minute soft lockout after 5-minute soft lockout, it would basically become a hard lockout, which would make someone come to and do an investigation. We get a call from the homeowner, things not running, my thermostat is blank, and I need you to come out. And that would be the only scenario we would actually ever have to see a hard lockout on one of these at all. So
And
kind of answers your question, Paul.
this is already happening. I've already been getting reports of people that had evaporator coil leaks with R32 that's out there, and they're having to go out. One of them was where the customer reset the equipment on their own before the technician got out there, and where people are coming out and checking. And it's also important to note, too, that that sensor is measuring for a leak before we ever get to that lower flammability limit of the refrigerant. I forgot what the exact percentage was, but it's actually doing the mitigation before we even get to the point to where that there even could be a flame in the first place. So that the abundance of safety is really high on these to make sure. And if we just follow these manufacturer's instructions, it's going to take care of this. Now, the board I saw today with Allied in particular was interesting because at the bottom of their board, it had controls on there for your zone controls. Does the board you have anything for zone controls on it?
Okay, so I thought about that for a minute. That question came up in my conversation. Is there a way for the unit to operate the zone control? And I had to think for a minute, and then I went, oh, yeah, it does have auxiliary contacts. So this particular one actually has 2 sets of auxiliary contacts that we could use. One of the questions that came in from Todd Clearer, if it was on a light commercial package unit that was required to be tied into an economizer, could we do that? Absolutely. We got a set of dry contacts. We could also bring that into any type of signaling device that we needed, particularly if our local codes required it for things like, hospice care facilities where we would want it tied into some type of an alarm. So they do have dry contacts to use for that. But I started thinking about this. When this goes into the state of mitigation, it calls for G, which should be our indicator to our zone control to open dampers for our airflow. So there are a couple ways that could operate. Call for G should take care of it for us. Also, we have auxiliary contacts that could be utilized for a zone control operation circuit.
What they were telling us in the class was they wanted to make sure that we didn't dump all of the air, all of that potential mixture into just one room, that we disperse it across multiple rooms. So they added the dry contacts for any potential for any remote alarms. And then if any of these zone controls had the dampers on it where they would open. So whether it was manually open or manually closed, vice versa, they could be wired in so that it was for sure, without a doubt, distributing it equally through the house. So we had a good dilution.
Diluted.
Yeah, it was quite interesting. And the one I saw today also had a place for 2 remote sensors because they're expecting that some jurisdictions and some locations could require a separate sensor in another location depending on how it was set up. So they had the option of having a place already built into the board, the mitigation board, for a second sensor, and then dip switches to set up to be able to program it to read for that. And I thought that was quite interesting.
That completely makes sense. I got 2 sets of outputs on here that I could utilize for different types of controlling.
We didn't
have. Oh, go ahead.
We didn't have any of these sensors in the past, but now we come to our senses.
Oh, we have finally come to our senses, haven't we? You've always got a great one to come back. Oh, I go. Oh, caught that one. All right, so let's think about this. So I went through my 5-minute period. Right, that was about 5 minutes. went through its sequence, started sampling again every 5 seconds, determined I was below the lower flammability limit. My system is reset. I am now back in my normal state of operation. So this is one control that we are going to see. We've seen a variety of different manufacturers have different controls. I want to show you a couple different ones. Like I said, Ty's got some pictures. I got some new pictures. We won't have those thrown in here for probably maybe tomorrow or a couple days. But what we're going to see as an industry, we are going to see mitigation controls similar to these in systems between 4 pounds and approximately 35 pounds. So it is 35.1 for R32 and it is 34 for R454B. Remember, it's determined by the mass of the refrigerant. So in that period in that stage between 4 pounds and approximately 4 pounds and approximately 35 pounds, we're going to have mitigation controls like these. Now, when we get into our communicating systems, we're already going to have these connections built into them. And as we continue moving, all of our furnaces and indoor boards will eventually have the 4-pin connector already established on it. So we're going to have this like little intermediate window where we will be utilizing these controls, because I can say that we absolutely will be doing that, because this is a installation manual for this major manufacturer on one of their 80% furnaces that will be hitting the market. And you can see that on it already has the R32 sensor, the 4-pin connector, landed on the factory furnace control board. And they also did our optional contacts, 2 of them. You'll notice up there on the top right has a 24 volt ventilation circuit, and it has the 24 volt A2L alarm, or just a separate secondary circuit. So we've added those controls onto the factory board for this furnace. I actually had a call about a year ago from a technical service advisor. Called and said, "Hey, Cliff, I know you're all over this stuff. ESCO is paying so much more attention to it than anyone in the industry, and I don't know what to do with this particular one. I need some help." I had my contractor call, said they got a brand new furnace. They went and they installed the furnace. It was a communicating system. As soon as they turned it on, they got an error code, A2L sensor not detected. I went, "Oh, sounds like you got a furnace that's not supposed to be out for at least another year." And he said, "I was wondering about that." So they'd actually received a furnace that had the A2L sensor built into the board, and so it was looking for the A2L sensor. So I advised him he was able to go through the menu, find that there was a menu option for that one for disabling that sensor to use for an R410 only system. And so, that was our first opportunity to see a board with the sensor built onto the factory board. And that was over a year ago. All right, so here's another manufacturer. By the color of that cabinet, you should recognize some of that. All right, so this manufacturer is supplying their sensor in the coil attached to the inspection cover. And then you have your intermediate board that you'll be installing between the thermostat and your gas furnace or your air handler. Right. So every manufacturer is having to make these transitions. I wouldn't be surprised if there's manufacturers that do not add the 4-pin connector to their gas furnace or their air handler, or maybe certain models, and in which then we will just continue doing the same thing, utilizing this intermediate board for those applications, even on new installations. Okay, here's another one. Should be fairly easily recognizable, right? This particular manufacturer has a sensor. It is that Sensata style sensor mounted behind a little plate in front of the coil. And depending on the generation of the board, if it hasn't been updated yet, it will soon. If it hasn't been updated, you'll be required to use an intermediate board for doing that. Good question. So Paul had another question about the units, right? Our manufacturer is setting up oil-fired furnaces with the A2L alarm. So I'm assuming this is going to be pretty standard across the industry going forward. And if it is not set up for that, then that's where we'll still be using one of these intermediate controls to be able to handle that. Because we already have manufacturers utilizing or manufacturing aftermarket controls. So this particular one, I can't get too detailed about it just yet. I won't get too close because I'm not supposed to. But I will say that this is one of my favorite aftermarket controls manufacturers. They supply most of the universal boards out in the industry that I kept on my van. And they have a aftermarket A2L mitigation board and sensor as a kit for all of our legacy controls using 24-volt thermostats. So
And if we think about
we
it
get
being a
what we
gas
want.
furnace or an oil furnace, if
Hmm.
we end that W, that call for W, if it's a gas furnace, we immediately lose our gas valve, losing our fuel for combustion. And then if it's an oil furnace, the same thing, we immediately shut off our fuel, like the fuel. We shut all that down, and so we're still going to run the fan. So the mitigation for the oil furnace is still in play, just like it would be a gas furnace. We end that W call, and we let the furnace take care of itself. So even if we don't have an oil furnace that has the controls built into it, if we have that mitigation board, we add that in, and it does the same solution.
Absolutely. So, Todd, to answer your question about the solid state controls, I can tell you on this aftermarket board, we're actually using mechanical relays that have sealed cabinets. On my Dragonfly, it's protecting in two different ways. It actually has an acrylic cover over all of our contacts with sealed rubber boots for all of our wiring connections. And it is using sealed cover mechanical relays, which I love heavy duty mechanical relays. I mean, they're
They work really
lightweight.
well.
They do. So, what we are seeing is we're seeing a few things changing to help make sure that our potential for ignition has been reduced as much as possible. One change, which is actually on this slide that I think is worth people taking a look at, is that many of our manufacturers have went with covered contacts on their contactors because, as we know, a contactor is only perfect. It's only in its original state one time, the very first time it's used. Every time that we separate, we actually create an arc and we do deterioration of our contact points.
And it's not
So
Noah's.
it's not Noah's point.
It's not Noah's Ark.
Not Noah's Ark. It's a different kind of ark.
Ark, ark, ark,
Ark,
ark,
ark,
ark.
ark, ark, ark. So you will start seeing a few changes on our outdoor units, but it's not much at all. Well, if we already have not seen a contactor with a cover, they've been out for a long time with quite a few manufacturers, we will start seeing covered contactors. I'm sure we'll see those or other heavier concealed controls for, especially with our air handlers, with our heating element controls. We'll also see on our compressors solid molded plugs with retaining clips if it didn't already have it. Our major manufacturer of many of our scroll compressors have been doing that for a very long time. So that is a potential change that we will see on some of that equipment. And
Um,
go ahead.
I was talking about that mitigation board. If we
Yeah,
think about a gas furnace, we have a window to where you can look in there and see the flashing codes that we've had for a very long time.
absolutely.
And with the mitigation board that I saw this week, they had it was for multiple applications, but it mounted outside of the box. Now, if you
Yes.
had a gas furnace with it already built in, you already have that window there. But if it was for an air handler, you needed to have some way to see it without taking off the
The
door.
door.
So in other words, if you're in mitigation, you don't want to take the door off and have it build up that level right in that closet space you're in. So this mounted outside, and the LED that was used was very bright, so that you could, it would get your attention. You could see the flashing lights, the codes, and see exactly what was happening. So I thought that was interesting how that was mounted separate. So even if we have the contact seal, it was in its own box and it was outside the cabinet, so it wasn't even in the airstream. So I mean, the abundance of caution is significant. So some of the things I look at, I think, man, that's just really overboard. But they've tested this. You get the lawyers involved. You get all the safety involved to make sure that there is no potential for this to happen. It's for if something to happen, there's going to be multiple failure points. And somebody always asks, well, what happens if this fails? And I always look at if you've ever watched some of these plane crash videos or some of these disaster videos, it's never one thing that went wrong.
All
It
right.
was like a series of things. All of these things happened in concession. And so for us to have an event, there would have to be so many different things that happened in a row for this. So all of these things, every step we do gets us one step farther away from any sort of an event. So like the relays, the controls, covered on a contactor. Ideally, that contactor wouldn't ignite it anyways on its own, but by putting a separate cover on there, we're just one extra step of safety, one extra step away. So all of these things add up together, and with our technicians following all the safety procedures we're supposed to do that we know we will be doing, this should be very safe. There shouldn't be any issues. But all of these things together is just an abundance of caution.
Yeah, it's a abundance of redundancy.
Yeah.
We have multiple layers of redundancy in there. And you're right, Joey. This is a question that we get often. If there was a failure in the system, would there be a potential for combustible reaction? Remember, if this thing has a failure, its primary failure would be if the sensor goes bad, right? That would be the primary failure within this. And here's the interesting thing about this: if the sensor fails, it actually does even then protect itself. So watch this. My sensor goes bad, no longer reads. I'm testing every 5 seconds. Edit. And within 5 seconds, my control board has recognized that my refrigerant detection sensor is not connected to the control. And so it now immediately goes into its state of mitigation as an additional step of protection for that. So, and if you haven't seen our video, Joey, on the flammability of these gases, it's very disappointing. It really, even if we had a failure of all of these, we still have a very minimal chance of catching things on fire. I said it's kind of disappointing. We tried really hard and we're not very successful at that, but we really, really tried. So we have done layer after layer of protection on these pieces of equipment.
So what you did was the same thing I did today at the Allied conference. Is I had to see, well, what would happen if the sensor malfunctioned, and so I unplugged the sensor and it went through immediately. So I saw that there was a problem, went through a check sequence, and then it went into mitigation. So I thought it was quite interesting, and it even had a code on there that says sensor failure, so it's already
Ooh,
looking for that.
exactly.
Now, you were talking about when you tested that sensor that it didn't have to be specifically R32 or specifically 454B that set that off, which brings us to a another point that other things could damage that, as with any sensor. And so at the conference for the Allied that I was at, they were talking about the importance of filtration, and filtration's always been important for the blower wheel, for the evaporator coil, for the drain lines. Drain lines notoriously are clogged up primarily for the dirt and stuff that we're not filtering properly for the customer's health. But now we need to be looking at filtration so that we reduce the issues of other contaminants that are inside that airstream going across that evaporator coil. And also, we've always supposed to have been looking at airflow in the past, but now we have to think about if we have improper airflow and we just, get away with it because it makes noise and it works, so to speak. Well, now if we have bad airflow, we've all seen this to where you have growth on the evaporator coils and you have that high level of moisture content. Well, it's almost always due to airflow. And if we have those same growth issues and that high moisture, instead of trying to fix the symptom, we need to step back and look at the actual ductwork issue, because that could cause an issue with these sensors having a premature failure. And it's not the sensor that's failing. We've failed the sensor by not having the proper ventilation and proper airflow that the units have always needed. But now these are some of the things that we're going to have to look for in our installation procedure. So just like we went from R22 to 410A, we were always supposed to pull deep vacuums, but we couldn't get away with it anymore.
You're right.
Yes, and so now we're looking at the proper ductwork, proper airflow, and we're always supposed to do that, but now we're having another step for that. And really, if you've seen the ECM motors, we see that there's constant ECM failures when we have really bad ductwork.
Absolutely.
So the motors itself have been telling us that we need to be concerned about the airflow more than ever before, because the PCS motor couldn't tell us that there was an issue, and now it does. And this is just another level of that same thing. So it just goes back to those best practices we're supposed to do. Those ages of cutting corners, we have to be more precise. And I also think about this when we deal with the ages of carburetors. You could have some bad fuel, and it kind of flow to the carburetor, and you kind of get away with some stuff. Then we went to fuel injection, which you get a lot more life out of the engine. Before we got like 100,000 miles, and now we get 200,000 or 300,000 miles out of an engine with fuel injection, and we can operate at multiple altitudes. But it also has a lot more high level of precision. Like, we have to make sure that we have cleaner fuel. The fuel filter is much more important than it was in the older days. And a lot of that kind of transfers today to where we think about, the filtration. We have better filter systems than we ever had before. And if we think about the quality of filters, we can have a high level of a MERV filter if we use a larger surface area. And now we have a lot of products out there that help us with this. Measuring airflow used to be, quite difficult. Now we have lots of products to help us with this. Doing a heat load calculation used to be very difficult. Now with products like
Minutes.
Conduit, you can do it with your phone as a built-in lidar in it now, and there's so many programs that can do this for us, and even companies that do this for us remotely. So there's solutions for every problem. There's a solution, and one of the things they had today was they had change, and then somebody had marked out being a problem, and they put possibilities. And so I think that's really important for us to look at is, hey, we having these changes, instead of looking at the problems, look at it, hey, there's going to be opportunities, there's going to be solutions. So when you're having other companies out there and they're just doing it the same way they've always done it, and now they're having issues, well, you can be the professional. It's an opportunity for you to come in and actually
do things
solve
right.
these problems and actually solve the ductwork issue or the sizing issue or the filtration issue. So it really opens up a whole world of possibilities for us. And we know that people here watching, they're the ones that want to learn. Nobody's here watching this being like, I hate this stuff. They'll leave a comment in the first 5 seconds, but the people that still here watching, you're the rock stars. You're the ones that we're here for. So think about these things as being, hey, this is an opportunity for you. To whereas there's always going to be somebody else doing it cheaper or faster, and now it's going to be another level for the customer to be able to communicate with us and look for that professional to really solve their problems.
I think that is going to show itself very quickly when we start talking about the labeling of this new equipment, which ironically was the next slide that I was going to get to. So that's the perfect segue time. I want people to understand that we're moving into A2L refrigerants. Yes, there is some slight flammability, not a ton. Jesse, thank you so much for joining us. Slight flammability, which means almost none. And we've done all the safety that we need to. Thanks for joining us, Garrett. We've done all the safety we can, Froggy, so that there is almost no potential whatsoever. But because of the very minimal potential, it has changed our industry. And there's going to be a lot of technicians that are completely caught off guard and not willing to look at these changes professionally, and they're going to struggle. And so you're right. It is this type of interest that is going to create the next generation of professional technicians.
So
Because, go
we
ahead.
all know in the field, if you're going to hire somebody, you can hire a contractor that has a contractor's license, who has the insurance, who has all the stuff to legally do the job, or you can find somebody else that does it on the side, or a handyman. No offense to handyman, but they're not a professional in the trade, and you have a lot of risk by using somebody that's unlicensed and not insured and all of that. And so now, as a homeowner, and they're seeing these flammability things, and they're seeing all these caution signs. It's the same thing that when I first saw those, I myself was kind of panicked. Like, what do you mean we're going to be using a flammable refrigerant?
Yeah.
Before I took the class? Now I'm going to be thinking, instead of us asking the same question the customer asks, we're the professional. We've taken the class. And something else that helps the customer be more happy that they've made the right choice in hiring the correct professional is, hey, sir, ma'am, I have the certification. I've taken all the classes, and if you're interested, I can explain to you all the mitigation and all the safeties about how this system actually works. So I think that's another great thing about having the actual certification. And we know that right now, at this particular moment, it's not mandatory that we take the certification, but why wouldn't we want to be professionals and actually have the certification, take the classes, and then that also gives our customer that extra level of assurance that they call the right person.
Absolutely. I mean, you take it a step further than that. We anticipate this happening through subsection H of the AIM Act. If it doesn't, we actually just had a call this week from a state that is going to be implementing it as a requirement for your state contractor's license. So we're going to have a lot of jurisdictions and distributors looking at this as requirements going forward. And as a professional, it is a way to distinguish yourself. Think about this, right? This is a R32 window unit off from the shelf of my local Costco, right? Homeowners are going to see these things and they're going to have questions about them. What if I'm the contractor, I'm the technician showing up with a box and it has this on it, and they notice that, and you don't have the correct information or training to explain that to them? Better yet, if you're going out to a job and you're having a conversation with the consumer about the next generation of product that they're going to be buying, and they've mentioned they're going to have a couple more estimates, and you go, by the way, I want to teach you about the new generation of refrigerants. And if anyone shows up to your door that doesn't know about these new refrigerants, you make sure that you don't let them in, and they'll be calling you back. Okay.
I've had 50 people in the last 3 months call me with a piece of equipment, and they found out that it was an R32 equipment, and they didn't know what to do. And that is not the time that you want to be having to figure that out. You want to have that ahead of time, and there's always going to be things to learn. But that, yeah, when you get that piece of equipment, like I can give you a crash course of the most important things, but you need to be taking that bigger picture, taking all the other steps. If I think about OSHA, OSHA is not legally required for everybody to have OSHA straight across the field,
Right.
but there's a lot of employers that require it. There's a lot of job sites that require it. There's a lot of states that do require that. OSHA doesn't mean that you're actually safer. It says that you've had the training and you understand the risk and the liability, and you at least know better when you do things incorrectly. And OSHA's been proved. I know a lot of people are against OSHA, but OSHA's been proved to reduce a lot of the risks. So things that we can call common sense, actually started from training or somebody else training and telling us stuff. And that's really what the OSHA side is. And so, if we think about these A2L, these mitigations and all these extra steps of safety, why not follow them?
Absolutely. It's all there for those extra layers of safety and communication. The communication is going to be key, because if you do not explain to your homeowner about these the very first time they go to change their air filter, and they see these stickers across the bottom of it, and the very top largest print says risk of fire, flammable refrigerant used to be repaired only by trained service personnel. Right on front of our covers, the homeowner is going to have an idea of this product if you haven't already explained it. So I think it's going to be very important for training, certification, validation, by showing our homeowners, our consumers, that we've been through proper training, certification, and be able to explain to them confidently the transition that we're going through. I think that's going to be the most important factor, is explaining it to the consumer and explaining it to fellow technicians as we're making this transition, because there's going to be a lot of that. So if you are looking for additional information on this, we could go so deep. That was like 5 slides out of like 90 of them that I had available. If you're looking for additional information on this, we want you to join us at the 2025 National HVACR Education Conference. Every technical trainer, from the equipment manufacturers that build this to the sensor manufacturers, we're going to have the refrigerant manufacturers. We're all going to be joining to dive deep into these conversations. If you're looking for training on that, it is as simple as going over to the low GWP refrigerant safety training, brought to you by us, right? That's what we're here for, is to help prepare you for all of these things. Yeah, and you're right, Froggy. There's going to be a lot of homeowners that don't know this yet. They're going to be very confused. If you are the contractor that shows up with a box with a flammable sticker on it, and you know that that homeowner is going to walk by as you're unboxing this, checking out their new product, and they see a flammable sticker on it, and you don't know what to tell them, they're going to tell you they want a different box. And there is none, because every manufacturer is going through this transition. We will no longer have R410A equipment as a system going forward. We're going to be moving to 32 and 454B. I've been to multiple distributors in these last couple weeks, and the boxes are showing up. I've actually encountered a contractor at every one of my training classes in these last 2 days that said they've already installed R32 systems. They just wanted to get better and understand what they were. And I was like, all right, you rock. That's what we're here for.
And this conference, we're talking about the HVAC Excellence Conference. When I started teaching, I was just overwhelmed with all of the stuff. I had to deal with everything, all the changes and stuff that I didn't have answers for. And when I went to this conference, it really changed my entire career, because there was so much information, people available, but not just that, also the networking. You get to meet people like Todd Clare, and you could have conversations like, hey, I'm having trouble with this. We need help. And then one day they'll ask you a question. And Jesse Stewart, if you ever get to meet Jesse with NAVAC, he's
I want to learn more about your tools. Let's go.
yes, he is like energetic and he loves what he does. He has a passion for what he does. You get to talk to Garrett Middleton. He's there. He talks about
Oh,
the stuff that he
absolutely.
does with his class. He'll tell you
Community
how
college
excited he
programs.
is with all the things that he does.
Mhm.
And we all really work together. It takes a village. And so all of us work together. We can get isolated in our little classroom and lab in the back of the school. But we need to be thinking what we do is so important. And so I remember I used to take my own personal vacation days and pay for it myself, my own time to go, but it was worth every penny of it. So that I got to really meet people, learn and networking, the manufacturers, and then also when you get to meet these speakers, a lot of times they'll give you their email, and then so you can reach out to them and ask them more questions, or they'll share their slides with you, and you get to see these products firsthand in the showroom, new tools, new equipment that comes out, and it's absolutely amazing. It is just it's incredible. There's over 100. We had I guess close to 100 different presenters coming in. We had 500 people apply.
Crazy.
We had to narrow that down to about 100. But today
That's
we
gonna
had 4 different classes or 6 different classes, I think it was total. And I was thinking about the HVAC Excellence Conference, which is like there's so many classes you can go to. You can't even get to all of them you want to go see. What a better place to go to get that education, information, and networking.
Yeah, absolutely. That's where I've met so many people, even on this show. People that come to the show will meet at the conference and go, "Hey, we got to talk about this. You're the right person. Let's get you on and let's go deeper into this."
And
So,
Todd Clare will help you see O2.
aha, love that. Woo! Somebody. All right. Well, thank you all so much for joining us. We're glad that you hung in with us. I know it wasn't the conversation we were planning on, technical difficulties. We're just going to postpone it, but we're fortunate enough to have this stuff. This is what we've been teaching on for the last 2 years. Now it's to the point where everyone's going, oh, we really do need to learn about that. So we've been building our resources, building all the material. We got you covered for your PowerPoint presentation for the classroom. We've got you covered for the books. We've got you covered for the e-learning course. We have comparative TP charts hot off the press that you can use in your classroom to compare R22, R410A, R454B, R32 classifications, GWPs, how they're constructed, everything that you need to be more proficient at what you're doing. So I love having you all here in our community. So grateful you joined us. Christina, so glad that you're here with us. Can't wait to see you all. And we'll catch you next week on Did You Know? The ESCO HVAC Show. Bye, everybody.